Okay, so here's a vectors question. So we're trying to find a scalar k. We're told that ON is equal to k times b. So we're not sure how far along this line it is. So OMA, ONB, and ABC are all straight lines. M is the midpoint of OA. B is the midpoint of AC. Right. So what vectors have we got? Also missing from this question, uh, we are given that MNC is a straight line. So let's draw MNC. MNC is a straight line. Okay, so let's put our first vector in. So OA is 6A, and M is the midpoint. So let's put the directions on OA, and we'll split it in half. So this is 3A, and this is 3A. Okay. OB is 6. Okay, so again, we'll put direction on, and that's 6B. Okay, well, we don't know where N is. We're not sure how far N is along that line. We've got to work that out. All right, and ON is KB, where K is a scalar quantity. So we're looking for this K. Right, so where do we start? Well, let's start with A to B. So to get from A to B, I'm going to go back up to O, and then from O to B. Okay, well, A to O is going to be minus 6A, O to B, and we're given that vector, that is 6B. Okay, now, how about BC? Well, BC, as B is the midpoint between A and C, BC must be equal to AB, because that's two equal halves. So that's equal to 6B minus 6A. Right, now, let's do, remember we said before, we'll take the longest vector, MC, from the beginning of that line to the end of that line. So how to do that? Well, I'm going to go from M to A. I know that vector. And then I'm going to go from A to B, which we worked out a second ago. And then I'm going to go from B to C, which again, we worked out. So MA is just 3A. Then I add AB, which is 6B minus 6A. And then I add BC, which again is 6B minus 6A. And simplify it. So I've got 3A, I take away 12A, so I've got minus 9A. And I've got 6B, I add another 6B, so I've got plus 12B. So that is M to C. Now, like the other proofs, what we're going to do is we're going to try to show that MC is equal to something times MN. Okay, same way we show it's parallel or it's collinear, it's a straight line. The longer vector is equal to a multiple of the shorter vector, but they're all on the same line. So what is MN? Well, to get from M to N, I'm going to go from M to O. And then I'm going to go from O to notation. I'm going to go from O to N. Okay, well, M to O is minus 3A. And O to N is K times B. Okay, that's the thing we don't know. In fact, we're given K by the question. So we've got that. So now, that means that, let's go back to this. We want MC is equal to something times N. Right, so MC, works out, is minus 9A plus 12B. And MN is minus 3A plus KB. Now remember, what we're looking for is a scalar that we can multiply the vector Mn by to get the vector MC. So what can I multiply this by to get this? Well, it's 3. Okay, so then I've got 12b and unknown b. So what I'm going to do is I'm going to divide it by 3. So that means that this would have to be minus 3a plus 4b. Now there's basically a constant ratio between the two. Okay, this is 3 times bigger than this. This is 3 times bigger than this. So that means that our answer is k equals 4. But a final answer.